Nice part about this section is it's largely the same as what we did in the last chapter. So for most of you, it'll be a pretty easy section. It gets a little bit into graphing stuff, kind of like we were doing in the last section as well. But solving inequalities by adding or subtracting. So first thing, if you're solving an inequality, if you notice what they're really talking about is now we're solving things like this. That's exactly like what we did in the last chapter, but in place of this, we just would have an equal sign in chapter 2, right?
Yeah.
Do you think you solve it any differently?
No.
Nope. So solving inequalities, treat the problem exactly like solving an equation. So exactly.
Oh, do we have to do it in caps?
So exactly, you don't have to. I was just trying to draw this as like exactly. Like solving an equation. You just copy the inequality sign instead of an equals. Copy the inequality sign like you did the equals. So in other words, if I want to solve this thing here, if it was an equal sign, we would have done what to both sides? Get rid of the minus 5, you add 5. So we do like a little plus 5 and a plus 5. And then you just recopy the thing just like before. We have an x on the left. But instead of the equals, you just copy that less than sign. And 13. Yes? So it's really identical to what you were doing. And now, a lot of times I'll have you graph your answer. So we're going to put a boundary at 13. Do we do an open circle or closed circle? Open. Nice, because it's not including 13. It's just the stuff less than 13. And if I want the stuff less than 13, I shade to the left, because that's where the numbers are that are smaller than 13. At the end of your shading, you put a big, awkward arrow, because otherwise your teacher marks you down and makes you mad. All right, should we do the next one? X plus 7 is greater than or equal to 13. So we do what to both sides?
Subtract 7.
Subtract 7 to both sides. Then I have an x all by itself on the left. Copy down the greater than or equal to. I get a 6, I believe. We're good? Then I have a 6 for a boundary. Open circle, closed circle? Closed, because x could be 6. It's greater than or equal to. If it's greater than, we shade to the right. And make sure you put an arrow on the end, and we're good. Any questions on those? Those feel okay? Nice. Limited domains. Be careful in story problems that the answer makes sense. Really what we're talking about is sometimes you can't have an answer that's a negative. Or sometimes you can't have an answer that's a decimal. Like for this one here, Mr. Falk bought some puppies to give away in class. Aww. Aren't I the nicest teacher ever? If 3 ran away and he doesn't have enough for everyone, how many could he have bought? So if you look at class, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 of us. So I started out with P puppies. Fair enough. So we'll say P. If 3 ran away, what are we doing to P? Minus 3. And now I don't have enough, so that means it's... So if I have, what do we say, 16?
15.
15? All right, 15. Less than. Less than or equal to? Or just less than? Less than, because not enough. Equal to means there's enough. 1 puppy for each person. But so P minus 3 is less than 15. So how many puppies did I buy or bring in?
18.
Yep, so you add 3 to both sides. So P is less than 18. But does P is less than 18 make sense in this case?
Yep. No.
So I could have bought 14.7 puppies?
No.
That's just kind of gross, right? You can't have it's not nicely. You don't want to have like a decimal puppy. I bought like negative 42 puppies. No. But so for the limited domain would be, I could have bought, I suppose, 0 puppies. But that doesn't really fit with the bought puppies. But I could be 1 or 2 or 3 or 4 or 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
And then stop.
16. 17. Well, not 18. But it's basically P is going to be integers, going to be non-decimal numbers, or you could say natural numbers, but less than 18. If we were to take and graph P is less than 18, And I don't know if I do this one because this is the wrong way, but you could put in an 18, be an open circle because it's less than, and be to the left. But we said some of those don't make sense because you can't really have like half a puppy without getting in trouble with, I don't know, the law. So for that one, instead, you should have like, really, we'd have to start at the 17. You could have 17 puppies, or 16, or 15, or 14, 13, 12, 11, 10, 9, 8. Probably going to run out of room. 6, 5, 4. Bummer. Oh, that's a really large eraser. That was my 4. So I need to have a 3, 2, 1. So 1. So your answer for one like this would have to be like a dot on each of those numbers to show that you can have only these numbers of puppies. So 1, 2, 3, 4, 5. We put a 5 in just for kicks. 6, 7, 8. But does that make sense? So sometimes your answer will have to be, they call it a discrete graph like this. It's not continuous. It's made up of a bunch of dots.